the initial velocity, or the initial
So there's not going to be three components to it?
displacement. All right.
Yeah.
So, a football is kicked at 37 degrees to the horizontal at 20 meters per second from the player's hand. Okay, so it's kind of a drop kick. At 1 meter from the ground. How far did the football travel before hitting the ground? So, in other words, here's the football field, or a rough approximation thereof. The ball actually starts up here, a meter high. It doesn't start from the ground. So it starts a meter high, kicks it at a 37 degree angle to the horizontal. So if this is the horizontal, kicks it at a 37 degree angle. It's going to follow an arc again, but this time it's going to hit the ground. So it's going to go a meter lower than before. So here's my 1 meter. All right, so 20 meters per second is my initial velocity. What direction is that initial velocity in? X, Y, or both? Both, yes. So it's along the hypotenuse of my triangle, 20 meters per second. So I'm going to have some VIY component of that and some VIX component of that. Some initial velocity in the Y direction, some in the X direction. SOHCAHTOA, right? So if I want to find VIY, which trig function shall I use?
Sine.
It's the opposite side, so sine. Sine of 37 degrees equals opposite, VIY, over hypotenuse, 20 meters per second. I can calculate that out real quick. Angle 37, sine times 20 gives me 12 meters per second in the Y direction. VIX, same process, except I'm going to use cosine because I'm using the adjacent side. Cosine 37 degrees equals VIX over 20 meters per second. That's adjacent over hypotenuse. Cup, right? The cup part of your SOHCAHTOA. Cosine times 20. 15.97, which we can round up to the tenths, would be 16.0. Okay, so I've split my 20 meters per second into two parts. I have 16 in the horizontal direction. I have 12 in the vertical direction. Now, put in the other things I know. We're discounting air resistance, so what's my acceleration in the X direction? 0. How about in the Y direction?
Negative 9.8 meters per second squared.
Yes. All right, now,
Oh boy.
what about my final velocity in the X direction? 16.0 meters per second. This should be 12.0 actually too. All right, so how far did the football travel before hitting the ground? So in this case, we're going to want to know the range. We're going to want to know the horizontal distance or the displacement in the X direction, dx. I don't have time, so I don't have enough over there on the X side to solve. Do I have enough on the Y side? Not yet. What is my displacement on the Y side? Negative 1. All right, if you think about it, it started from a meter high, so he kicked it up here. Pretty good. I got this. Kicked it from a meter high. It then hit the ground, which is a meter lower than that. So total, from start to finish, it started a meter high. It ended down here. So my total displacement in the Y direction is negative 1 meter. Not as nice to deal with as 0 meters, but still doable. This makes us have to use our quadratic equation if we want to solve that first equation. So, if you pass on the quadratic, which you can, I don't care, you can then solve for VFY, use that to solve for time with your third equation. So that's what we'll do right now. just for the people who don't remember the quadratic. All right, so I'm going to use this equation to solve for my final velocity. Vf squared equals Vi squared plus 2AD. All of this is going to be in the y direction. All right? So, Vfy squared is what I'm solving for. I'm going to solve for Vf. Viy is 12.0 meters per second. It's a decimal. There we go. Squared plus 2 times negative 9.8 meters per second squared times negative 1 meter. So, negative 4.9 times negative 1 gives me 4.9. Meters cancel out, leave me in seconds squared. Excuse me, meters squared per second squared. All right, so meters actually multiply by each other. So 4.9 meters squared per second squared plus 12 squared, 144.
Isn't it 2 times though, so like 19?
Oh yeah, you're right, I'm sorry.
Okay, you're doing the
Good catch.
distance formula. Cool.
Good catch. All right, 2 times negative 9.8 is negative 19.6 times negative 1 gives me 19.6 meters squared per second squared. Thank you. All right, so this also meters squared per second squared because I have meters per second squared. Meters squared per second squared. So 144 plus 19.6 gives me,
163.6.
what is it?
163.6.
63.6 meters squared per second squared equals VFY squared. Square root. Both sides. 163.6. What is it?
12.7.
12.79 meters per second. So, final velocity. Positive or negative? Negative. How do I know? Starts out going up, it ends up going down. I know that if I have the square root of something, I have a solution set of a positive and a negative. In this case, I have to choose the negative because I know I'm moving in a downward direction. All right, so I went through all that to solve for my final velocity. I dropped the eraser just to show you how gravity works. Now, over here I have 4 variables. I want to solve for time. That means I can use any equation I want to. What's the easiest one to use? Bottom one was pretty easy. Final velocity equals negative 12.79 meters per second equals, by the way, the initial equation, I should say, since we're doing a video here, VI plus AT. So, VF is negative 12.979 meters per second. VI is going to be 12 meters per second, plus acceleration is negative 9.8 meters per second squared times t, which I'm going to solve for. So first of all, subtracting 12 from each side, I get what? Negative 24.79 meters per second equals negative 9.8 meters per second squared times t. Now I can just divide each side by negative 9.8 meters per second. 8 meters per second. So, 24.79 divided by 9.8, both negative, so it'll be a positive, 2.53 meters per second. Solving for time, this is meters per second squared, meters cancels out, one of my seconds cancels out, leave me in seconds. So 2.53 seconds. That answers my question, doesn't it? Good. What else do I need?
Distance.
In the x direction, I need displacement in the x direction. So, I have a time now. Remember that first equation is going to be the most useful one to me, the x direction. dx equals bix times t. Remember the 1/2 times a times t squared portion is going to be 0 because acceleration is 0. So I just have to multiply my initial velocity of 16 meters per second multiplied by my time of 2.53 seconds. That will give me my displacement in the x direction. So
40.48.
40.48.
40.5.
40.5 seconds cancels out, leaves me in meters. 40.5 meters.
Nope, nope.
So, just because the ball fell that extra meter, started out a meter higher than the ground, kicked it at a 37-degree angle from the horizontal, that gave us a displacement of -1 in the y direction. Could have added another fraction of a meter to this distance had he kicked it from the ground. So that -1 meter could have added just a little bit more onto the x direction. Good? Questions? Turn this off again.